Artificial intelligence is no longer staying inside screens. It is moving into bodies, machines that walk, machines that lift, machines that inspect, machines that work in the physical world. And that is why the next great AI race may not be in chatbots alone. It may be in humanoid robots. For years, artificial intelligence felt mostly digital. You saw it in software, in chatbots, in recommendation systems, in image generation, in search, in coding tools. Even when the systems were powerful, they still seemed trapped inside screens. That is now beginning to change. Artificial intelligence is moving into machines. Real machines. Machines with sensors. Machines with limbs. Machines that can operate in factories, warehouses, research spaces, and eventually public environments. This is the beginning of the humanoid robot race, and it matters because it changes the meaning of AI itself. A chatbot can reason in language. A model can classify an image. A recommendation engine can optimize feeds. But a humanoid robot brings intelligence into the physical world. It must see, balance, move, grasp, navigate, react, and operate under uncertainty. That is a very different challenge. It is one thing for AI to generate text. It is another for AI to function inside a moving body in an unpredictable environment. This is why humanoid robots matter. They are not just another device category. They are a test of embodied AI. Embodied AI means intelligence that does not only compute, it acts. It senses the world and then attempts to function inside it. And once intelligence becomes embodied, the stakes rise quickly. Because now the questions are larger. Can robots work in factories? Can they reduce labor bottlenecks? Can they support logistics? Can they assist in inspection and maintenance? Can they operate in dangerous environments? Can they be deployed at scale? And eventually, can they become economically useful enough to transform entire industries? That is why the humanoid robot race is no longer a novelty story. It is becoming a strategic technology story. We can already see this in the market. Some companies are using humanoids as research platforms. Some are positioning them as future industrial workers. Some are treating them as a long-term operating system for the physical economy. And different countries are beginning to see them through different lenses. As commercial opportunity, as manufacturing leverage, as AI leadership, as national security risk, as industrial policy. That is what happens when a technology stops being a demo and starts becoming strategic. Consider China's position. Reuters reporting shows that Unitree has moved aggressively in the humanoid segment, shipping 5,500 units in 2025 and taking 32.4% of the global humanoid market. That alone shows this is no longer a science fiction niche. It is becoming a serious industrial category. Reuters 1. That scale matters. Because in hardware markets, volume creates learning. More units mean more testing. More testing means faster iteration. Faster iteration can create cost advantages, supply advantages, and deployment advantages. This is one reason the humanoid robot race is so important. The firms that move first may not only gain publicity, they may gain real manufacturing momentum. And in embodied AI, momentum matters. Because the challenge is not just making a robot move once, it is making it robust, safe, adaptable, affordable, and useful. That takes repetition. It takes field experience. It takes integration between hardware, software, sensors, motors, control systems, and training data. This is why Unitree's rise has attracted so much attention. Not simply because humanoids look impressive, but because they may represent an early manufacturing advantage in a category that many people assumed was still years away from relevance. Reuters 1. At the same time, the race is not only commercial, it is increasingly political. Reuters reports that U.S. lawmakers are pushing a bipartisan bill to ban the federal government from buying or using humanoid robots made by Chinese companies, citing national security concerns and the possibility that such machines could be remotely controlled or used for data collection. Reuters, Sui, Na? That is an important signal, because it means humanoid robots are no longer being viewed as harmless gadgets. They are being treated as potential infrastructure. Infrastructure with sensors. Infrastructure with mobility. Infrastructure that can exist in physical environments where trust matters. Once a machine can move, see, hear, and potentially interact in the real world, the security logic changes. A humanoid robot is not just an app. It is a system that can enter physical space. That raises different concerns. Who made it? Who updates it? Who controls the data? Who controls the software? Who can override it? Who can inspect it? Who can trust it? These are the kinds of questions that turn a product into a geopolitical issue. This is why the humanoid robot race sits at the intersection of three major stories: artificial intelligence, industrial automation, and strategic power. It is not enough for a company to build a robot that can walk. It must build a robot that can do useful work. That is where the real battle begins. Dancing robots go viral. Factory robots change economies. And that is the distinction that matters. A successful humanoid future will not be built on choreography. It will be built on reliability. Can the machine repeat tasks? Can it operate for long periods? Can it avoid failure? Can it be maintained economically? Can it function safely near people? Can it justify its cost? That is the hard path. This is why humanoid robotics is such a compelling field. It concentrates many of the hardest problems in technology into one machine. Mechanical engineering, battery limits, motor control, computer vision, real-world navigation, dexterous manipulation, safety systems, on-device intelligence, cloud coordination, industrial integration. It is a stack problem. And like all stack problems, progress is uneven. One company may have strong mechanics but weak intelligence. Another may have strong control software but weak economics. Another may have scale but not enough capability. Another may have great demos but no path to industrial deployment. This is why the race remains open, but it is clearly real. And it is spreading beyond one company or one country. Hyundai plans to deploy Atlas humanoid robots at a US factory from 2028, starting with part sequencing and moving to more complex tasks later. That shows the industrial use case is no longer theoretical. Reuters 3. That point matters. The humanoid robot race will be won not by the most cinematic demo, but by the most credible path to deployment. Where do these machines create value first? Factories, warehouses, inspection environments, hazardous spaces, controlled industrial settings. Not because those are the most glamorous environments, but because those are the environments where constrained, repetitive, high-value tasks can justify the machine sooner. That is how many major technologies scale. They begin in narrow use cases. They improve inside structured environments. Then if economics work, they spread outward. The same may happen here. This also explains why embodied AI may become so important to the next phase of the technology cycle. For years, AI value has been concentrated in digital tasks: search, language, media, customer service, code, planning. Humanoid robots extend that logic into physical labor and physical operations. That is a much bigger economic frontier. If AI can move from generating text to helping run physical systems, then the impact expands from the digital economy into the material economy. Factories, supply chains, construction support, inspection, maintenance, logistics. That is where the stakes become larger. And that is why this race deserves more attention. It is not only about whether robots become common, it is about which countries and companies define the operating system for machine labor in the physical world. That could become one of the biggest platform battles of the next decade. Who builds the bodies? Who builds the control systems? Who trains the behavior? Who secures the supply chains? Who integrates the robots into real workflows? Who sets the safety standards? Who earns trust first? These are not demo questions. They are market formation questions. And market formation questions usually determine who leads. There is also a symbolic dimension. Humanoid robots capture imagination because they make AI visible. A data center is powerful, but distant. A model is intelligent, but abstract. A humanoid robot is immediate. It places intelligence in a form people can see, judge, fear, admire, and imagine living beside. That makes humanoids culturally powerful even before they become economically dominant. And technologies that are both symbolic and strategic tend to move quickly. That is why the humanoid robot race is now worth watching closely. China is scaling. The US is reacting. Major industrial players are testing deployment. And the field is moving from spectacle toward competition over real-world usefulness. Reuters 2. The long-term outcome is still uncertain. Many companies will fail. Some products will disappoint. The hype will outrun reality at times. But the direction is clear. Artificial intelligence is no longer staying inside software. It is entering machines. And once AI enters machines, the race changes. It becomes a contest not only over models, but over bodies. Not only over computation, but over action. Not only over information, but over physical capability. That is the humanoid robot race. And it may become one of the defining technology battles of the era.